Alright, here is your video on the chapter portfolio. So first we're going to kind of talk about maybe some background information, for stuff in Algebra 1 that maybe you didn't quite grasp. Either you didn't grasp fully whenever you first had it in Algebra 1, or maybe your Algebra 1 teacher really didn't do a fantastic job of really explaining the background behind the stuff that you were doing. So my first question to pose to you here is, what's the difference between these two lines? What's the difference between this line on the left and this line on the right? And you might go, I'm going to have to say, just because this line is on the coordinate plane? Is that really the only big difference between those two lines? Because, they look like they're roughly the same line, but this one's just graphed versus this one's not graphed. Is that really the big difference? And yeah, pretty much it is, but let me dive a little deeper in here. So this line is made up of infinitely many points, right? So this is like what we did in geometry in chapter 1. We can have infinitely many points that are on this line, and we can name those points specifically, like A, B, C, D, etc., etc. But the problem is we can't pinpoint the exact location of those points. Like if I had point A up here, how do you really describe to someone where exactly point A is at on that line, right? You can't really give a specific location for it. And so that's going to tie into having our line on a coordinate plane. So this line is still made up of infinitely many points, but each of these points that are on here have their own x comma y location, right? So all of these points, x comma y, x comma y, x comma y, but they're all different x comma y's, right? The x's are different, the y's are different. But now we can pinpoint exact locations if this line is graphed on an xy coordinate plane, on a Cartesian coordinate plane. So how can we determine the relationship between each of those infinitely many xy points that make up the whole line, right? Like if I have this xy versus I have this xy versus I have that xy versus that xy, what is the relationship that all of those infinitely many xy points have with one another? Well, that's where we got into, or I'm not going to say we, because we haven't covered this in Algebra 1, but this is what you would have talked about with equations of lines. And so we've got our good old y equals mx plus b. This was slope-intercept form of a line. And so the line, the linear equation here, really represents that relationship between x and y. And so what we would do is we would take our values of x, we would multiply them by m, which was the slope value. We would take that value and add b onto it, which was the y-intercept value, which I'll get into here in a little bit. And once we did all of that math right here, well, then that would give us where y should end up being on that line. Okay? So if you wanted to know, again, what the relationship is between each of those infinitely many points that are on a particular line, this is where we get into equations of lines. This gives us that particular relationship. So first with m, which again is the slope. You guys were first introduced as slope as being the rise over the run. So we have a vertical change, which is our rising, going up and down on the y-axis, over the run, which is our horizontal change, which is that difference in the x direction. All right. Last chapter when we did Pythagorean theorem, we didn't directly talk about slope per se, but we used that idea of rising and running to help make a right triangle, so we could use the Pythagorean theorem. Now, mathematically, the slope, you would have two coordinates. So let's just say coordinate here. Let's call this x1 comma y1. That's our first coordinate. And let's say I have a point up here and I have it x sub 2 comma y sub 2. So if I took the first y coordinate and subtracted away the second y coordinate, that would give me my vertical change, my rise between here and here. And then if I subtracted my x coordinates from each other in the same order that I subtracted the y coordinates, then that would give me my running or my horizontal change. And that would be my slope, right? And so that works for any 2 points that are on the line. So it doesn't have to be this point and this point. It could be this point and that point. That slope, this rise over run, is the same as this rise over run. And you might go, but that can't be. This rise and run is smaller than that rise and run. And I would say that's true. So when we talk about slope, we're talking about ratios. And all of those ratios of rise over runs are equal to each other. They are proportional to one another. It's kind of like saying, well, this rise over run, maybe it's 1 over 2, but maybe this rise over run is 5 over 10, and maybe this rise over run is 4 over 8. And all of those rise over runs are really equivalent to each other. Now, the y-intercept specifically is where the line crosses the y-axis, and the y-axis is the vertical one. So where that line hits the y-axis, so I've got a little star right there, that is a specific point. Now, any y-intercept, the x value is always 0, because on the x-axis, here is where x equals 0, specifically right here at the origin, right? But our point is either going to go up b, which it does in this case, or if b was a negative value, then we would go down on the y-axis. So the y-intercept is specifically a point, 0, whatever the y-intercept is. And again, that could be a positive or a negative value. So we talked a lot about parallel lines this chapter, so let's keep the momentum going, but now we're going to put it on the coordinate plane. Okay, so we did proofs with parallel lines, but we didn't graph those, okay? So I've got a line, okay, here's my line, and I've got this point just kind of hanging out here, this point at 4, -2. All right, and this is going to lead us into the types of problems we're going to work on. So I've got here infinitely many lines can go through the point 4, -2, right? I could have a line go this way through 4, -2. I could have a line going this way. If I made those straight lines, which here, let me go grab my straight line tool. I could have this line, I could have this line, I could have that line, and I could just keep going all day long. Theoretically, I could always put a new line in between 2 old lines, and this thing just starts to get a little crazy, right? So infinitely many lines can go through the point 4, -2, but now here's the real question. How many lines can go through 4, -2 out of those infinitely many and are also parallel to this red line? How many? And you know what? There's only going to be one such line. So I can make a parallel line, right? There's infinitely many parallel lines to this line, but there's really only going to be one parallel line that's going to go through that specific point and still be parallel to this red line. So that's the first question. That's the first type of problem we're going to explore here, is now, what is the equation of that new line? So what would first be really helpful is if we knew what the equation of this first line was. So that's what I'm giving you right here. The equation of that line is y equals 5/6 x, or 5/6 times x if you need to see the multiplication in there, plus 2. And so again, let me kind of break down what that means again. So first the slope, it's rising and running, 5 rising, 5 rising, 6 running. And the y-intercept is at a plus 2, which means on the y-axis, our line crosses the y-axis at a positive 2 value. So right there. So from there, I could rise 5, 1, 2, 3, 4, 5, and run 6, 1, 2, 3, 4, 5, 6. And so then if I connected together those points and went forwards and backwards, there is the line, okay? So the thing to know about parallel lines is that they have the same slope. So we already know one thing about this line that needs to go through this point and needs to be parallel to this red line, is we know that it also has to have a slope of 5/6. So here's again what we know so far. We know our slope is 5/6, so y equals 5/6x, but then plus b. Just because they're parallel doesn't mean they're going to have the same y-intercept as well. Then that would be the same line, and they would be right on top of each other, and then they would intersect infinitely many times. All right, so I've now updated this. How can we figure out the equation of the line? So we know y equals 5, 6x plus b that goes through 4, -2 and is parallel to our red line. So like I said, now we need to figure out what the y-intercept is. Now, here's what we can do, just kind of tentatively right now, is could we estimate what the y-intercept value is going to be for this line? And we could, right? If we have this on a graph, where does this line cross the y-axis at? And it crosses it right here. And we can kind of see it's in between two numbers. Is it directly in the middle between two numbers? Like, what do we got here? -1, -2, -3, -4, -5. So it's somewhere between -5 and -6. Can I assume that it's at -5.5? And no, you can't assume that it's at -5.5. But looking at the graph, it appears to be that it's somewhere between -5 and -6. So how do we actually figure that out? So here I've got, remember, the y and x in the equation, right? This y and this x in this equation represents infinitely many x comma y points, right? So on this line, there's all of these x comma y points, but there's infinitely many of them. But we need to know just one point that's on this line. And do we know just one point that is on this line that we need to figure out? And we do. It was that one point that I gave you at the very beginning of the problem. Right? We know the point 4, -2 is on this line. Now, where did the 4, -2 come from? I gave it to you. It's given information, if you will. Okay? So now here's what we can do with that 4, -2, is we can take the equation of our line, what we know so far, and it would be really helpful if we only had b as the variable. So this y and this x, again, represent x comma y points that are all on this line. And so we said, we know one point. We know this is the point 4, -2. So what we're going to do is we're going to substitute, and this is a temporary substitution, but we can substitute in -2 for y, and we can substitute in 4 for x, because 4 is the x-coordinate and -2 is the y-coordinate. So we got -2 equals 5, 6 times 4 plus b. And now we can figure out what b is. So what I did first was I made this 4 into a fraction because my slope is a fraction. And so how do we multiply fractions? And multiplying fractions was the easy thing because all you had to do was multiply straight across. Multiply numerator with numerator and denominator with denominator. And so keep in mind, if you need to put a denominator underneath this 4, you can always put a 1 underneath it, right? Because 4 divided by 1 is 4. So if I multiply these, I'll have -2 equals, and then I'll have 5 times 4, 20 up top, and then 6 times 1, 6 on bottom. And then plus b, if I can make that look more like a legitimate b. There we go. Now, algebraically, all I need to do is subtract this 26ths over, and someone might be saying, wait, could we simplify 26ths before I subtract it over? Yeah, you could simplify it if you wanted to before you subtracted it over, sure. I'm going to end up simplifying it in the very, very end, though. But either way is completely fine. So now I need to subtract 26ths from -2. And so what I'm going to do is I'm going to take, and I'm going to make this more of a mental math problem. Mental math, what's that mean? So I'm going to convert this -2 into a fraction of sixths so that I have common denominators so that I can add the numerators. So what number divided by 6 would give me the same thing as -2 overall? Well, it'd have to be -12, right? -12 divided by 6 is -2. So -12 sixths is equivalent to -2. So now -12 sixths minus 20 more sixths gives me how many sixths altogether? Well, that would leave me with -32 sixths. It's not like I have a lisp, I know. And now here's where I could simplify my fraction, right? Because what could go into 32 and 6? I could divide both of those by 2, and so really b ends up being negative 16 thirds. And I'm going to leave it as negative 16 thirds. Is that the same as negative 5 and a third? Yes, it is. But I'm going to leave it as an improper fraction that has been fully simplified. So there's the y-intercept. And remember, this was negative 5 and a third. Where did we think it was going to be at down here? We knew it was going to be between negative 5 and negative 6 just based on the graph. And is negative 5 and a third between negative 5 and negative 6? It is. And notice it's not exactly between negative 5 and negative 6. It was actually a little bit closer to negative 5 than it was to negative 6. So now let's pull this all together. So here now is the equation of this blue line. It's got the same slope as the red line. So again, remember, they both have the same slope, but they were going to end up having different y-intercepts. The red line had a y-intercept up here at positive 2, but we figured out that the blue line's y-intercept was down here at negative 16 thirds, aka negative 5 and a third. All right, now the last little thing I have to say here about this problem is in the end, when you write the equation of your line, only the slope and the y-intercept can actually have numbers associated with them. So this means you need to make sure that you're using y and x back in here. And you might go, yeah, but we plugged in negative 2 for y and we plugged in 4 for x. And you did. You did that so that you could figure out this negative 16 thirds. But once you figured out what the y-intercept is, now you're going to reconvert back your negative 4 and negative 2 into its original y and x. So this is the final answer. This is the equation of the line, this blue line, that is parallel to the red line, and it goes through this specific point at 4, negative 2. So now we're going to switch gears up here. Instead of parallel, what if I wanted to find the equation of the line that still goes through 4, negative 2, so it's still the same point, but instead of it being parallel, I want to find the equation of the line that's perpendicular to the red line. And so the red line, same exact equation as before. So I'm going to keep this nice and simple here. So I've got geometrically, perpendicular lines mean that when they intersect, they're making 90-degree angles, right? They're making right angles here. Now, numerically, and this is where we're going to need this more than anything, numerically on a graph, perpendicular slopes are what we call opposite reciprocals, or you might see them referred to as negative reciprocals. So what does that mean? What is the opposite reciprocal, right? Because this red line had a slope of 5/6, so the blue line is going to have a slope that is the opposite reciprocal of 5/6. Well, let's break this down here, and I'm going to start with reciprocal. Do you guys remember what reciprocal meant? Reciprocal meant you're going to take your fraction and you're going to flip it upside down. You're going to make the numerator the denominator, and you're going to make the old denominator the new numerator. So the reciprocal of 5/6 is 6/5. But now the opposite means you need to take the opposite sign of what you had. So this 5/6 was a positive 5/6. So the opposite of our positive 5/6 is going to be a negative value instead. So you're going to switch the sign from positive to negative or negative to positive, depending on what the original slope was. And then you're going to flip the slope upside down. Okay? So the slope of this line is going to be negative 6/5. And let me just throw in another what if here. What if the slope we were given, what if the slope was 4? What is the negative reciprocal of 4? Again, this is a theoretical what if side question here. Well, what number goes underneath 4 always? 1. So flip it. Now you get 1/4. This was positive 4, so this would be negative 1/4. So you can always take a whole number, convert it to a fraction with a 1 underneath, and then flip it and switch the sign. So here's what we know so far. We know that this blue line, it's got a slope of negative 6/5. So now we're in that same position we were in earlier with our parallel lines, right? We need to figure out what the y-intercept's going to be, because we know the slope, but we don't know what its b value is, the y-intercept. We can look at the graph and go, hey, look, it looks like it's slightly above the red line's y-intercept at 2, right, plus 2, but it doesn't quite look like it's at 3, right? And so what is that number that it's hitting at right there? How about we algebraically figure it out, and then we don't have to guess what it is? So again, this blue line has infinitely many x comma y points on it. And it would be great if we only knew just one of those x comma y points. And do we know any points that are on this line? Hey, we do. We have that 4, negative 2 again. So we're going to use that 4, negative 2 in really the same exact way that we did it if this had been a parallel problem. So the only real big difference here between doing a problem where you need to find the parallel line and doing a problem where you need to find the perpendicular line is really at the beginning with the slopes, right? Parallel slopes are the same. Perpendicular slopes, you got to flip and switch the sign. And then how do you find the y-intercept? It's really the same process in both problems. So here's where I'm at right now with my blue line. I know the slope's negative 6/5, but I need to substitute out the y and the x so that my only variable is b, the y-intercept. So again, I'm going to substitute out the y with the negative 2 because that was a y coordinate that I know is on this line. And I'm going to substitute out the x for the 4 because again, I know an x of 4 with a y of negative 2 is on this line. And then once again, I converted that 4 to a fraction, so 4 over 1. And now I need to multiply my slope with my x coordinate here. So this will be negative 2 equals, so again, multiply across. Now, this is a little bit different because I have this negative. Does the negative go with the 6 or does the negative go with the 5? And to be honest with you, it doesn't matter. Okay, but it doesn't go to both. Because if the 6 was negative and the 5 was negative, what's a negative over a negative? It's a positive number. But this is overall a negative slope. So I typically take the negative, if the fraction is negative, I usually just apply it to the numerator. Okay, so we'll call this negative 6 times 4 is negative 24. Negative 24, there we go. And then on the bottom, 5 times 1, 5, plus b. So now I need to add over this 24/5 to my negative 2. And again, we're going to do some mental math here. I'm going to convert this negative 2 into a fraction of fifths. So what number divided by 5 would give me negative 2 as an answer? Well, negative 10 divided by 5 would give me negative 2 as my answer, right? So negative 10/5 plus 24/5 gives me, what, 14/5? So there is my y-intercept. And again, you're going to leave it as this improper fraction. Does 14/5 simplify? And it doesn't, because 5 is a prime number, and the 14 on top doesn't have a factor of 5 in it. So just real quick, 14/5, what is that? That's what, 2 4/5? 2 4/5? So that tells me that right up here at 2 4/5, that's where the blue line hits the y-axis. And hey, that looks pretty reasonable, right? We said it was almost at 3, but not quite at 3. And 2 4/5 is 2.8 if I wanted to express it as a decimal. Okay? So yeah, that looks great there. So now we just need to finish this up. So now here is the equation of our blue line. It has a slope of negative 6/5. It is the opposite reciprocal of our red line, but it had a different y-intercept, right? And we had to solve for what that was. And again, just keep in mind, your final answer for your equation must now have a y and an x in it. We get rid of the 4 and the negative 2. Those were just temporary substitutions so that we could solve for b. Now, last but not least, what if I'm given the equation of a line and it's not in y equals mx plus b format to start with? What if it's not in slope-intercept form? And all I mean by that is, like, I gave you from the get-go that the red line had an equation of, oh no, I messed this up. This should be 5, 6 still. Boop, my bad. Just caught that error. And if you caught it before me, kudos to you. But now I can try to remember what I was going with here. Oh, yeah, I gave you the equation of this red line, that it was y equals 5 6x plus 2. But what if it's not written perfectly in y equals mx plus b format? Like, what if I gave you the equation of the line and it's in standard form? Or what if I gave you good old point slope form? How do I convert these so that they look nicer like they're in slope intercept form? You're just going to have to move some stuff around. So let me just show you these two examples real quick. So for standard form, I want this to look like y equals mx plus b. So I need to solve for y. I need to get y all by itself. So first thing I would do, I would move these 6x's over to the other side. And so I have 8y. And then usually the mx comes first, right? So that's where I'm going to put the negative 6x. And then plus 12. Could you have written 12 minus 6x? Yes, but then it's more in like b plus mx format, which makes it a little bit different looking. And then in the end, I can divide both sides by 8. But here's the deal. You need to divide each term by 8. The y term by 8, the x term by 8, and the 12 we would call the constant term. It is a constant value. That 12 is a 12. There's no variable attached to it. So in the end, these 8's cancel. So we're left with y equals, and then we might have to do some simplifying. Negative 6/8. Well, that's negative 3/4 simplified, x, plus, now we got to do some more simplifying. What's 12/8 simplified? Well, 4 can go into both of those. So fully simplified, that would be 3/2. And so now here's like your red line at the beginning of the problem. There's its y equals mx plus b. All right? And what if we had point slope form? Now this one's a little bit nicer to work with in some cases, right? Because we almost have y all by itself. We just got to get rid of this plus 4. But then the other issue is over here, right? We got this negative 2/3 times the quantity x plus 7. So I tell you what, first thing we'll do is we'll distribute the negative 2/3 to both the x and the 7. So I got negative 2/3 x. And then, again, think of that 7 as 7 over 1. Multiply these fractions. This is going to be minus 14/3. And then I'm going to need to add this 4 over to the negative 14/3. So I'll get y equals negative 2/3 x. And then this is where I need to be able to combine these. And again, I'm going to encourage you to use some mental math here. So I need a fraction of thirds to match up this fraction of thirds. So how many thirds is equivalent to 4? Well, 12 thirds is equivalent to 4. So what is negative 14/3 plus 12 thirds? Well, that would be what? Negative 2/3. And so now there's the equation in slope-intercept form. And now you can more easily work with that. You can see the slope is negative 2/3. The y-intercept just happens to also be negative 2/3. Okay? Just a coincidence that the slope and the y-intercept are the same there. All right, so now you guys can try these problems out in your portfolio assignment. And if you got any questions, you need me to check anything, let me know.